See, like I keep saying, binomial theorem is one topic where, just using that one formula, the TR plus 1 equal to NCR, A power R N minus R, B power R. So that is the only formula, and you can solve, any kind of problem. So whatever problems will be based on only that. Okay, so a topic where you can easily score. So just think, based on that formula, various, scenarios. Is that what is being generally asked? So this is one example. So the number of rational terms in the expansion of 3 to the power of 3 by 4 plus 5 to the power of 3 by 2 whole to the power of 60. So I think Akshaya, in the problem last week, I didn't solve it, but to that problem before this we solved, and there were a few problems that were left out, and this is one of them. Okay, so did you have a chance to look at this, Akshaya?
Yes, sir.
Did you try this? Try to solve this? What is your experience? Like, what did you do, and
No, sir, I haven't tried it yet.
Okay. See, நம்மளா ட்ரை பண்ணி பார்க்கணும். I keep repeating. Okay, so பண்ணிட்டு வந்தீங்கன்னா, where what step was difficult for you, so you can focus on that and learn. Okay, so otherwise, நானே சொல்லிட்டு இருந்தேன்னா உங்களுக்கு effective இருக்காது learning. Okay, that's why I keep repeating this. You should try, these problems yourself. You are going to write IIT entrance examination. You are going to face, these kind of problems, right? So should practice. Okay, so let me explain this. The number of rational terms abdina, the power, the exponent should be integer. Okay, if the exponent is a fraction, like what is given here, 3 by 4, 5, 3 by 2 and all that as exponents, they are irrational. Okay, so when you expand it to the power of 60, there will be some terms which will be rational, and some terms will be irrational. So all we have to do is count the number of rational terms. Okay, so all we have to do is do the expansion of this binomial theorem using binomial theorem. So what you will get, the first term will be 3 to the power of 3 by 4 to the power of 60. This is your a. Okay, this is a plus b whole to the power of 60 is NC0 into a to the power of 60 plus NC1 into a to the power of n minus r, that is 60 minus 1 into 5 to the power of 3 by 2 whole to the power of 1. This is, and the last term will be 5 to the power of 3 by 2 to the power of 60. So they here 60c 60. The first term is 60c 0. So I'm leaving it out because they equal 1. So this is the binomial expansion. So the term will be rational when both the exponents are integers. Like in this case, 3 to the power of 3 by 4 into 59 and 5 to the power of 3 by 2 into 1. So this is not integer, right? 3 by 4 into 59. Similarly, 3 by 2 into 1, this is also not integer. First one, let's take the first one. So 3 to the power of 3 by 4 whole to the power of 60 is 3 to the power of 15. So it is a rational number. Okay, so this is rational. Okay, so after that, this is also irrational, this is also irrational, so the net is going to be irrational. So next term, if you see, this is irrational, whereas 5 to the power of 3 by 2 whole to the power of 20, so that is rational. So this is also not sufficient for us because there's one irrational and one rational. The whole term is going to be still irrational because both the terms should be rational for the term to be integer or the term to be rational. Okay. So now all we have to do is count where all the first part, this will be integer, and where are all the part where it will not be integer, that is irrational and rational. So so let us take the first term, 3 to the power of 3 by 4 whole to the power of 60 onwards it starts. After that it is becoming 59, 58 and so on. So we can see which terms will be rational. This is rational. When the exponent is 60, it is rational. So next, when it will be rational, 59 by 4, not rational. 58, not rational. 57. Then 56 will be rational, right? Because 3 by 4 into 56 is an integer. Then after that again, there are going to be 3 irrational terms, and then 52. And so on. So that means this is T1, okay, then T5, okay, or I will say when R equal to 0. R equal to 0, R equal to 4, eight, so these are the rational terms as far as the first term is concerned. Now look at the second term, which is 5 to the power of 3 by 2 whole to the power of R. Okay, when R equal to 0, so this exponent is 60 minus R, right? So the first one is 60 minus R. The second is simply R. So when it is 0, it is rational. Okay. So here it is rational. After that, 60 corresponding exponent for the second term is 0. So this is rational. After that, when it is 1, it is not rational. But when it is R equal to 2, if you see 5 to the power of 3 by 2 whole to the power of 2 will become rational, right? Because 3 by 2 into 2 is integer. So when R equal to 2, it is rational. Then R equal to 4, R equal to 6, R equal to 8, and so on up to R equal to 60. So when R is 0, both the terms are rational. So we get a rational term. When R equal to 2, this is rational, that 5 to the power of 3 by 2, that part is rational, but this first one is not rational. So that whole term doesn't become rational. So when R equal to 4, again it becomes rational. So R equal to 8, it again becomes rational and goes up to R equal to 60. So all we have to do is count the number 0, 4, 8 up to 60. How many terms are there? How can we count this? This is simply an arithmetic series, right? 0, 4, 8, 12 up to 60. So how many terms are there in this? This is a series, arithmetic series with a equal to 0, d equal to 4. So the nth term will be a plus n minus 1 into d. Okay, so nth term is, now we know that it is 60. So what is n? So that is what you have to find out. So 0 plus n minus 1 into 4 equal to 60. N equal to 16. So that is the answer. Right, Akshaya, are you following?
Yes, sir.
Yeah. So why are you not participating? You should also you get and simple steps. So you should come forward and solve them, right? Instead of just be doing this like a monologue. Okay. Okay.
Sir,
Yeah.
I'm actually traveling right now. That's why I've logged in from a different device, so I'm not in a position to do the sums, sir.
Okay. Okay. So let's look at the next problem. The only thing is I don't mind it. No, I will keep solving it, but it's not going to be effective for you. That is why my concern. Okay. It's going to be effective to some extent, right? Not like you doing it yourself. Okay. The remainder when 7 power 103 is divisible by 17. So how can we do this? So what we do is 7 when we divide by 17 we write it as mod 17. The remainder when divided by 17 is 7 mod 17. So we know 7 mod 17 is 7. Right? When you divide 7 by 17 the remainder is 7. Quotient is 0 and remainder is 7. Now what happens when you do 7 square? 7 square is 14. It is still less than 17. So your remainder is again 14. Now we need to go to 103. So we cannot go on like 2, 3, 4, etc. But now we can start jumping. So from 2 we can go to 4. So what is 7 power 4? Seven square mod is 14. So 7 power 4 mod is this one squared, right? So you don't have to do 7 power 4 now. All we have to do is 14 square. Okay. So you simply do 14 square divided by 17. Okay. 7 square is 7 square is 49. When you divide by 17, I took it as wrongly as 14. So it is 49 divided by 17. You get 34. 2 times 17 is 34 plus 15. So 15. Okay. Now instead of doing 7 to the power of 4, we can do 15 square, which will give a smaller number. So that is the principle we are using here. So if you take 15 square, which is 225, and you divide by 17, you get so 7 power 4 will be 4. So we can easily calculate in this way. So from 7 power 4, you can easily go to 7 power 8. So you are squaring it, right? So this will become simply square. Now you see the 16, the moment you see something like 16, which is very close to 17, right? So 16 is same as minus 1. Okay. because the mod, that the property is that you can keep adding n times this 17. The my value doesn't, they are equivalent. Okay, so the mod, whenever you get a mod of -1, it is same as -1 plus 17, which is 16. So similarly, the 16 is also equivalent to -1. So now once you get something like a -1, you can simply do 7 to the power of 8 whole to the power of 12. Okay, or for that matter 13. Okay, so that means 7 to the power of 104 we can do, whole divided by mod 17. Right? So since we are taking 13th exponent of 7 power 8, so it will still be -1, because 13 -1 to the power of 13. So 7 to the power of 104 is going to give a mod of 1, -1. Another thing that we can do is, so let us say 7 power 8 whole to the power of 12. Equal to 1, right? -1 to the power of 12. So now we need 7 to the power of 113, right? 103. 103 can be written as 7 power 96 into 7 power 4 into 7 power 2 into 7 power 1, right? So this product mod 17 will be, so what is 7 power 96 is 1, and 7 power 4 is 4. 7 square is 15 into 7 power 1. So we can do like this. So 240. So 240, 240, now you divide by 17 and write a remainder, that will be the result for this. Okay? So that we can do quite easily, 240 divided by 17. So this is 2. Okay? So this is your 7 power 103. That will be 2. Okay. One minute. Something wrong here. Let me check. Seven power 8 is 16. 7 power 104 is -1. 96 6. I'm getting a wrong answer. I'm just checking. Okay. 7 power 96 is 1. 7 power 4 is 4. 7 square is 15 into 7. No, it's not 240. So 4 into 60 into 7 is 420, right? So 420 when we divide by 7, 2 17s or 34, 80. Again, no, 4 17s or 68, remainder 12. So the remainder is 12. So this is your answer. So this is the property of mod that you are using. Okay, so when you keep on um, squaring or taking a third power or multiple large number of powers of a number, the mod property is that mod you can do the same operation in mod, which will be relatively easier, and that way you can keep calculating the mod values of higher exponents. So you can even calculate 7 power 1000 and 2000 and all using this approach, right? Once you have reached this plus 1 or minus 1, so then it is simply a matter of you do any number of power, it's going to be simply 1 or minus 1. So that way you can do this. Okay, let's look at this problem. Sum of the first Akshay, are you comfortable with this so far? You have reached home now?
No, sir.
Okay, because you changed your login, so okay. Are you comfortable with this approach? Do you follow
Yes, sir.
yeah, because this kind of remainder problem is I see very frequently asked, so you should know this technique. Okay, so let's look at this. Okay, so this is a series problem. Sum of the first 20 turns of the series 5, 11, 19, 29. Okay, so this kind of series is also very frequently asked. So this kind of series is neither arithmetic nor geometric, nor arithmetico-geometric also, because if you take the D's, the differences. So here the difference is 6, here the difference is 8, here the difference is 10, and so on. So if the difference is constant, we call it as AP, but the difference is in AP. So this is a kind of series that are very easy to solve. I think we have done this earlier also, I think. I'm not sure if we covered in our class. Um, we solved problems from a book, no? I probably solved one of the problems of this type. But the method, do you remember, Akshaya, about how to solve this problem?
Yes, sir.
So how will you solve? Okay. So you simply write S once again like this. This is up to 20 turns, right? So what is the 20th term? So that we can calculate, right? Let's say T20, whatever, T20, okay? 5 up to T20. So here you write this like this, 5 plus 11 plus 19 29 and so on. So here you are going to get T20 is going to be pushed here. This is going to be T90. Five plus 6. No, this, I'm sorry, that is for AGP only we can use this, sorry, arithmetical geometry. So here what you do is different. See, if it is like arithmetic series in this manner, the differences are in arithmetic series. What we do is you try to express, let's say T1 equal to 5, T2 equal to 5 plus 6, right? And T3 equal to 5 plus 6 plus 8. And T4 equal to 5 plus 6 plus 8 plus 10. So you see it goes like that. Because the differences are increasing, it becomes like 5 plus 6, 5 plus 6 plus 8, 5 plus 6 plus 8 plus 10, and so on. So now the T1, T2, etc., the Tn can be calculated using the arithmetic progression. So what will be your T20? Equal to 5 plus, see here this T4, there are 3 terms like this, 6. So T3, you have 2 such terms. So T20, you'll have 5 plus, so this you'll have 19 terms. See, this is a arithmetic series. So that is what makes us easy to solve. So we write the general term for Tn in this manner now. So if you say Tn now, okay, so Tn is 5 plus, so this arithmetic series up to n minus 1 terms. So 5 is your first term, and then the since the differences are in arithmetic series, so the term Tn formula becomes an arithmetic series. This we can solve easily, right? 6 plus 8 plus up to n minus 1 terms. What will that be? Where A, here A is 6 plus n minus 1. So here's only n minus 1 term, so it will be n minus 2 into D. That is the last term. So this sum we have to calculate, right? So this sum, let us calculate this using A equal to 6. D equal to 2. Let us say this m, okay, number of terms here, we'll keep it as m, okay, equal to n minus 1. Because I don't want to use the same n, it will be confusing. Okay, so what is your sum to n terms, sum to m terms here? Sum to m terms will be, we have to find out the mth term. So what is your mth term? Tm equal to, so that is, what is this formula? 6 plus 2n, 6 plus 2n minus 4, 2n plus 2. Okay, so your mth term is 2n plus 1. So the sum to m terms here will be m by 2, n minus 1 divided by 2. Okay, then into Ta plus the last term. So first term plus last term into number of terms divided by 2. So basically first term plus last term divided by 2 is your average into number of terms. So that is an easy way to remember. Okay, so 6 plus 2n plus 2. 2n plus 8. So I can take n minus 1 into n plus 4 into 2. 2n plus 8 whole divided by 2. So it simply becomes n minus 1 into n plus 4. Your the sum of this series. So that is your Tn. That means I will expand this n square plus 3n minus 4. So all I have done is Tn equal to 5 plus, 5 also is there, right? So I have to put a plus 5. So all I have done is this Tn equal to 5 plus this. So this is an arithmetic series. I use the arithmetic series formula to get the sum in terms of n. So I added 5. So that is your Tn. So once you know Tn, then what we really need is the sum of this series up to n terms or 20 terms. So that means S n equal to sigma n square plus 3 sigma n plus n. இப்படி போட்டுடலாம். We know sigma n square, sigma n and the value of n. So Sn equal to, since Tn equal to n square plus 3n plus 1, so Sn will be sigma n square plus 3 sigma n plus n, because n times 1 is n. So this is equal to S20. So we want the sum up to 20 terms later. So you simply put Tn equal to 20. Sum to first 20 terms. S20 will be sigma n square up to 20 terms, n into n plus 1 into 2n plus 1 whole divided by 6 plus 3 n, the n into sigma n is n into n plus 1 by 2. The n is 20. So now we have to just simplify. Seven into 41, 7, 28, 70 plus this, I'll cut an icon. 2 into 20, 3 into 21, 63 into 10, 630. So you get 3520. So this is the general approach you use whenever you see, something like the differences themselves are in arithmetic series. So all you do is you can derive Tn in terms of n, and then use the formulas like sigma n square, sigma n, etc. Sometimes it may be cubic also, so you know what is the value for sigma n cube also. So so that way we can solve it. Let's go to the next problem. 21 to the power of 18 plus 20 into 21 to the power of 17 plus 20 square into 21 to the power of 16. So this is equal to, if we have to get it in terms of some k into 21 to the power of 19 minus 20 to the power of 19. So we have to get it in this form. Okay. So usually, I mean, when they give a problem like this, when we do this summation, it will come in that form. So then we'll have to find out what is k. Okay. So what type of series is this? if you see between the first term and the second term, there is a multiplication by 20 and division by 21, because the 21 power goes down by 1, so that means division by 21. So 20, it's multiplied by 20. So add multiply by 20 and divide by 21. So look at the next term, again multiply by 20, divide by 21. Again it goes on like that. In the end, as you know, the 21's exponent goes on decreasing, so that the sum always remains 18. So finally 21's exponent becomes 0 and 20's exponent becomes 18. So it is simply a geometric series. Okay, so the geometric series with a equal to 21 to the power of 18, r equal to, so you multiply by 21, no, multiply by 20, divide by 21. Yeah, so a equal to 21 to the power of 18 and r equal to 20 by 21. So in this series, starting from 18 up to 0, 21 exponent was 18 in the beginning, it has become 0. 20's exponent from 0 to 18. So number of terms is all numbers from 0 to 18 means 19 including 0, right? 0, 1, 2, 3, 4 up to 18. So we have a, we have r, we have n, and all we need to do is sum of the geometric series with these parameters. You remember the formula for sum of geometric series? S equal to a into 1 minus r to the power of n divided by 1 minus r. So we have the values of a, r and n. It's a matter of just substituting in the values here. So a is 21 to the power of 18, 1 minus r to the power of n, whole divided by 1 minus r. Equal to 21 to the power of 18. So let me put this as 20 power 19 by 21 to the power of 19. So I can take 21 to the power of 19 here and write this as 21 to the power of 19 minus 20 to the power of 19. Whole divided by 1 minus 20 by 21 is 1 by 21. This is 1 in the denominator. When you have 1 by 21, it is same as into 21. So, but let me finish the numerator first. 21 to the power of 19 minus 20 to the power of 19 divided by 21 to the power of 19. And now coming to this term, this is 1 by 21 in the denominator, which is 21. So that simply becomes like this. So now you see the question, it says k into 21 to the power of 19 minus 20 to the power of 19. So we got it nicely, 21 to the power of 19 minus 20 to the power of 19. So apart from this, whatever else that remains is your k. Right. What remains? Here 21 into 21 to the power of 18 is 21 to the power of 19. So denominator is also 21 to the power of 19. So it just simply gets cancelled. It simply becomes, that means k equal to 1. Okay. So k equal to 1. They're given that option 2, right? Okay. Let's do this problem. These are some slightly tricky problems. 1 square minus 2 square plus 3 square minus 4 square, etc. so if you have to convert it into this form, m square n. Okay, so then we find out n minus m square and all that. So the basic problem is doing this summation of the series. 1 square minus 2 square plus 3 square and so on. Okay. So the challenge is how to do this sum, because we know the sum of 1 square plus 2 square plus 3 square, 1 plus 2 plus 3 and all that. But this is like, there is one negative and positive and so on. So how can we do that? Okay. So actually there are two ways of doing it. So the first way, which is very obvious way, is you write this as 1 square minus 2 square, okay, plus 2 times 2 square. Okay, so this way what I do is this minus 2 square, I make it into plus 2 square. So because I know the sum of 1 square plus 2 square plus 3 square, right? So I can simply add 2 times 2 square and subtract 2 times 2 square. Similarly for others also. 3 square. 3 square I don't do anything, because it's once I'm able to convert it into 2 square, 3 square will perfectly fit in the square series. So similarly 4 minus 4 square is there, so I want to make it plus 4 square, so I do it 2 times 4 square I add, and negative 2 times 4 square and so on. So basically what I have done now, this is basically plus 2 square. So this I am keeping as it is, 3 square. So here again, 2 minus 4 square plus 2 times 4 square is simply 4 square. So I have converted it into basically a square series. Okay, we have to look at the last term now. So what is the last term here? Pi square plus 2023 square will come as it is, and the term before that minus 2022 square plus in 2 times 2022 square minus 2 times 2022. I would have done like this. Okay, so that means it ends here. So this is your 2022 square. So up to that, previously we would have had 2021 square, which we didn't touch, and so on. So it would have become 2022 square. Now we have taken this all pluses. Because we did the plus, we have to do the minus. So all the minus terms, what are all the minus terms that will remain? Minus 2 into 2 square. Up to 2 into 2022 square. So the point is, this series we can straight away write the formula. We have the formula, and this series also we can solve easily, because you take out a 2. Okay, I'm leaving it out. Okay, so this is your, I'm calling it as S1, and this I'm calling it as S2. S2 equal to S1 minus S2 னு வெச்சுப்போம். So இந்த இப்படி பிராக்கெட்ல எடுத்துட்டோம்னா எல்லாமே பிளஸ்ல வந்துரும். So S1 minus S2, where S2 is 2 into 2 square plus 2 into 4 square, etc. So 2 can be taken common, 2 square plus 4 square. Now this also we don't know 2 square, 4 square. We only know 1 square plus 2 square, etc. Right? So this can be written as 2 into 1 they're all into, okay, not dot 2, not like 2.2, okay. Which is equal to 2 times. So in all these terms, we can take a 2 square out. Okay. Then this is 1 square plus 2 square plus 3 square. So 2 into 2 square is 2 cube. So let us say 8. So it becomes 8 into okay. So now we know how to solve this S1 and we know how to solve this S2. So solve them and do S1 minus S2. We get the answer. Okay. So what is your S1 here? 2022 into 2 times or n into n plus 1 into 2n plus 1. 2n is 40, 44, right? So 40, 45. N into n plus 1 into 2n plus 1 whole divided by 6 minus your S2 is 8 into 1 square plus 2 square up to 1011 square is n into n plus 1 into 2n plus 1. Okay. So this itself is looking like a big multiplication. Okay. But there are certain things we can take out as common. Okay. For example, so here you have 2022. So 8 into 1011, I can write as 4 into 2022. Okay. Into 1012 into 2023 divided by 6. Okay. So why I did like that is now I can take out this 2022 and 2023 common. So what remains is 4045 by 6 in the first term. In the second term, 4 by 6 into 1012. At this stage, I can try to simplify it, or let me leave it. So 4 into 1012 is 40, 48 divided by 6. Then there's something wrong. Okay. 22, 2023. Ah, So what we missed is 12023 square here. Okay, so this is where this should be up to 2023. Okay, so 2023 is also there, right? So in the S1, if we include 2023 square, then it would have become 2023 into 2024. Okay. Because this is coming to negative, and that series is not negative, it is positive, because I can see that 1 square were positive, 3 square minus 2 square is positive, again 5 square minus 4 square is positive, and again 2023 square minus 2022 square is positive. So the sum of all positive numbers, it cannot become negative, and also the option is all having all positive. So we can conclude there is something wrong in the step. So that is why spotted where I missed the mistake. Okay, so this we have to simplify now. Bit laborious. So all we can do is take out a 2023 by 6. The 2022 by 6. Then here you have I hope I didn't miss anything. So 2020, 24 into 40, 45. Oh, again I have missed something, because this is the 2023 into 2024, and this will be 40, 47. Because 2n plus 1 is 40, 47 here. So you have to probably we can use a calculator and solve it. Okay, and okay. So here you see in these two terms you can take this 2024 common in these two terms. So that means we can take 2023 into 2024 whole divided by 6 into 40, 47 minus 2023 into 2, because we have taken only 2024 out, so 2 will remain. So if you see this 40, 47 minus 40, 46, so this is 1, so this goes away. So all that remains is only this now. Okay. So this is 6. 10, 12 into 2023. I think I missed another 2 somewhere. Okay. I think I have to redo it. Okay. Let me redo this. So S1 and each one I will do separately to make it easy. S1 equal to 20 up to 2023, right? So that means it is 2023 into 2024 into 4047 whole divided by 6. Okay, and S2 equal to 8 times, right? 8 times this 1 square plus 2 square up to 1011 square. 8 into 1011 into 1012 into 1023 whole divided by 6. Eight into, sorry, 1011, 1012, 2023. So this one we can write it as 4 into 1011 into 2024. So now I can take this 2023 into 2024 common by 6 also. So what remains in the first term is 4047 and what remains in the second term is 4044. Right? 4 into 1011, which is 4044 is what remains. And this is simply 3. You can cut it out and put as 3. And this is simply 2. 3 into 2, 6. So this becomes 1012. So the net sum that we want is S1 minus S2, which is equal to 2023 into 1012. Okay. Now this is equal to, they are given as though this is not enough. They want us to do some more work. So this is, we have to write it as m square into n and find out the value of m and n. M square into n. So now we have to find out what are the common factors. Okay, 2023 into 1012, right? So this becomes 2023 is 7 into 289. This is 7 into 289. This is 4 into 253. So these are the perfect squares that we can take out. This is 17 square. That means this we can be written as 34 square into 7 into 253 is 7 3s are 21, 2, 725 is 175, 177. So your m is 34 and n is 1771. So this series, if you try to write it in the form of m square into n, that's all we can get perfect squares, because 253 you cannot do anything further. Okay, so therefore m equal to 34 and n equal to 1771. And what are they asking? N minus m square. Again, n minus m square equal to 1771 minus 34 square. And what is 34 square? 1156. Okay, 650. So your first option. Okay, so the point is that this kind of series we can do some small manipulation, and there is another. I said there are two ways, right? So this is one way. The another way is looking at this 1 square minus 2 square plus t square, etc. Right? So this is an straightforward way one, but this is more complex. Actually, I should have gone down the other one first. Just wanted to show the different methods. Okay. It's all your algebra 2023, right? See, this one you keep as it is. Okay. No. Square. Plus, so this is 3 square minus 2 square. This is 5 square minus 4 square. This is 7 square minus 6 square. So you can write like this. So by simply rearranging and rewriting in this way, you can see that 3 square minus 2 square is simply 3 plus 2 into 3 minus 2. So 3 minus 2 is 1. So this is, let's say this is 1. This is simply 3 plus 2. And this is simply 5 plus 4. Similarly, this is simply 7 plus 6. And the last term is simply 2023 plus 2022. So it becomes a simple arithmetic series. Okay. So 1, 5, 9, 13, etc. up to 4045 is a simple arithmetic series whose sum will be A is 1, D is 4, L last term is 40, 45. So you have to find out D, A plus N minus 1 into D equal to L. So you find out N from this. 1 N minus 1 into 4 equal to 4044. N minus 1 equal to 4044 divided by 4, 1011. So N equal to 1012. So if you got N equal to 1012, A equal to 1, D equal to 4, L equal to 4045. So the sum will be N by 2, right? Or N by 2 into A plus L. into 2023. So we got the same thing, yes, in that approach also. 2023 into 2012, which afterwards we converted into 34 square into 1771. So So you can more easily arrive at that step. So just as I'm trying to demonstrate, this is what we should do actually. The second approach is faster, but the first approach is more straightforward. So it looks like that is the easy way, but there is a better way also. Okay. So okay, so we have solved some 5 problems, right? So I think it is time up. So I'm going to ask you to do these remaining problems. Okay. Similarly, unless you people practice, it's not going to be effective. So you please think and see. It's not rocket science. It's fairly all these problems we can do. Arithmetic progression, geometric progression, and binomial theorems, simple formulas. Sometimes it is laborious, like in the last problem, but you can still do it. We will do it carefully. You will do it right. So I'm going to ask you to do it, and so we'll meet in the next class. Okay. Okay. Akshaya, any questions, Akshaya? Hello, Akshaya, are you there?
Yes, sir.
Okay, ma. Okay. Take care. Bye.
Thank you.